Right, here we go. 6.3 is a continuation of 6.1 in that it also deals with proportions. The difference is now we're going to have two different groups. What does that mean in terms of being able to use the normal distribution? Remember in the last 6.1, like there was just these two conditions to check. Which again, to keep it real simple, it's the idea of checking that your sample size is large enough so that if you were to bootstrap it, would the shape of it be, you know, relatively close to the normal distribution, so that we could use the normal distribution to get our estimates for standard error, confidence intervals, p values, and that's still what's happening here, except now we've got a second group, which means it's going to have its own separate two conditions that we have to check. Now, when I say that there's going to be two different groups, it could be like in this situation, for example, one, where we've got Arizona and we've also got Alabama. And what the study was doing was checking to see whether, what's the proportion of residents living in both of these states who have been born outside the US. And from a census, you can see that they got 13.9% for Arizona and 3.4% for Alabama. And what I want us to do here is just right now, just kind of splice this into like a top half and a bottom half. Primarily the top half, all I want to do is just collect information. And what that's going to be is that when they did the proportion for Arizona, it came out to be 13.9%. For Alabama, it came out to be 3.4%. Again, all I'm doing here is turning both of those purely into decimals so that way they can work nicely with other decimal numbers. But what we're going to end up needing as well, I'm just going to put circles around them, are the complements of them. So we're going to go and do that. The complement for Arizona, which would be 1 minus 139, and then also the complement for Alabama, which would be 1 minus 0.034, is going to give us 861, and then also 0.966. Again, we're going to keep these together. That's Arizona stuff, and then we're going to keep these together. That's Alabama stuff. But notice we'll also need sample sizes for the first group and the second group. And they tell us right here to use 500 for each group. So sample size for Arizona will be 500, and the sample size for Alabama will be 500. Now we're going to check the conditions. Again, before we go on to use this formula, which is going to be associated with um, the normal distribution, we want to check our four conditions. So right now we're focusing just on Arizona, which I'm going to do Arizona here and here, is to take the proportion and multiply it times 500. And all we're checking is to make sure that it comes out to be something that is 10 or bigger. We've got 500 times 0.139, which is 69.5, which is good. Shows that's an appropriate sample size to be using. Then we'll take the sample size of 500 and do times the complement. So it's these two being multiplied together now. Like, so each of the proportion and complement both get a turn to dance with the sample size, and that one also is really good. So 2 check marks, 2 to go. We're now going to work on the same two, the same thing we're doing here is just 500 times the 0.034. This is now working on the Alabama. 2 multiplications we need to do. And again, as long as these both come out to be 10 or more, we're good. Now I'm going to do the 483 one first, just to kind of keep us in suspense. You're going to see that this last little calculation that you do here is the one that comes out to be, whoa, that one was, smaller compared to all the other ones, but at least it was still bigger than 10. Now, the comment I want to make is that, yeah, this one's good. Little check mark. So by doing the little check marks, that's just me saying, we got a green light, green light, green light, green light, that we can go to use the formula, that it would be a nice way to get standard error. And then at the same time, use that along with the normal distribution to get our confidence interval standardized, get p-values. But on the homework, there's going to be one, and it's actually kind of out of order too. They're going to have you use the formula first and then check the conditions. I know that feels sort of like backwards, but do it. What's going to happen on the homework is when you check all four of these, there's going to be one of them that doesn't work. And let's just say this one had come back as being just like 7, then we would have put a little X like, nope, not good. That means we shouldn't use the formula. But on that one, I want you to still use the formula anyhow. I know it sounds kind of like, wait, but you just said we don't use the formula if the conditions don't check out. For the homework, I still want you to do it anyhow. But it would mean in the real world, right? If we were actually applying this to some study, and our sample size comes out as not being, large enough, conditions are not checking out, it would just be that we shouldn't use the normal distribution because shape-wise, it's not going to be the best shape, to be matching ourselves up to, and instead we should go ahead and revert back to using the bootstrapping in as we did in chapter 3. But at this point, we're good, right? At this point, we got all like little check marks, and what we're going to do now for the formula, which is a big one, it's going to be the square root. And just think about it this way: this is the Alabama stuff. No, let's do Arizona. Arizona was like our first group, and Alabama, which it doesn't really matter. Keep your Arizona stuff together, keep your Alabama stuff together, or whoever your first group is. And so we're going to do I got it on the screen there. We're going to do the 0.139 times its complement, which is the 861 over 500 plus 0. Now this is moving on to Alabama, which is the 0.034 times the 966 over 500. And that's what you would put in your calculator to get. But try it. You should get 0.017. Again, you got to spend some time figuring out like what it is that your calculator needs you to do. Does it need parentheses? Does it not need parentheses? Does it need you to do the multiplication, division, addition, multiplication, division first, and then the square root at the very end? Calculators are all can be a little different. Now, keep in mind that this is not the same thing as doing square root of some stuff plus square root of some stuff. No, it's all one big square root housing everything. Now, this first page is meant mainly to set us up with this formula, which is to get us standard errors. I do realize that I'm missing a little 1 here. Maybe this is an old version that I'm using right here. Hopefully yours has the little 1 and little 2e. On this example, we're going to be calculating a confidence interval. You can see they're prepping us for that. It's going to be a 90% interval, so they're already giving us what should be, times SE when we get there. And then they're also reminding us of this little formula. whenever you have two groups. Should we be checking conditions? Yes, but for some of these, we're going to assume that the conditions are like okay for us to use the normal distribution. Now, in this example, I want you to take a moment just to read to see what are the two main groups that they're comparing. And I also want you to think about part A, that what fractions it is. I'll give you that much. I'll give you that much. It is going to be that there's going to be a proportion for group one minus a proportion for group two. And I want you to spend a little bit of time right now figuring out like what are the two fractions that you're multiplying based on who the two main groups are and what they're focusing on is happening. The response, the main response that they're focusing on. I also want you to write here to consider just putting the decimals for both of those fractions and then ultimately get your statistic right over here. And let me be quiet for a little bit. And actually, one more thing before you do this. And you're looking at this, I want you to scratch out whatever row or whatever column like you're not even going to need because they're not even focusing on that particular response. Again, pause the video, do part A. Okay, so here's what happened. Notice that they were focusing on two main group wise smokers versus non smokers. And then they were also focusing on who got pregnant. So we don't even need this. And look, lo and behold, there are the fractions we need. They're focusing on how many got pregnant for smokers, which would be 38 out of 135, and up 206 out of 543 from the non smokers. So we got several things here. We've got sample size for smokers. That was 135 that smoked. The sample size for non smokers was 543. So we've got smokers minus non smokers. We've got 38 over 135. We've got 206 that got pregnant out of 543. And then now for our decimals, which I recommended doing, we got 281 for the smokers and 379 for the non-smokers. I'm going to put it right here. Smokers, non-smokers, those are their proportions. And as far as the statistic, it came out to be negative 0.098, which is suggesting that if a woman smokes, that they're maybe about 10% going to be less likely that they're going to, like a 10% lower proportion that get pregnant. So that's our statistic. Now, for the standard error, the formula is way up at the top, and it's the one that needs these, your two different group informations. And I'm going to start with first putting in the smoking information. So you've got 0.281, and now we need the complement, which let me just do that way up here at the top. 1 minus 0.281 is 0.719. 0.719. Here, let me make sure my little multiplication here looks like a multiplication out there. And then their sample size was the 135. And now let's focus on putting in the non-smoking stuff information. So we have the 0.379. They had 543. And now we just need the complement. I'm going to do it way up at the top. 1 minus 379 is 0.621. So again, I'd recommend just off to the side doing the little subtractions to get your complements. That way it's a little bit easier for your calculator to digest. And again, try this one. 0.044 should be the standard error that we get. And then now we're going to use this and this to get our confidence interval. I'm going to keep that in the page, but it's the statistic first minus 1.645 and plus 1.645 times our standard error, and that's going to give us our lower and our upper value. And again, I'd recommend doing the subtraction first. That way you get your smaller number, and then do your plus version to get your larger number. Again, go ahead and try that first without me. And then all I'm going to do here is just start working a little bit on the usual interpretation that we do, at least the starting of it. 90% confident that the difference in proportion. All right, but again, it should have come out to be negative 0.17 and negative 0.3, which all that's doing is now widening the idea of how much lower the proportion of those that get pregnant if they smoke could be as low as like 17% or 3% lower than the non-smokers. And then we're just going to finish off this interpretation. Again, it's always, I think, a good idea just to use, like, reuse the words that they have in the prompt. This is about women who get pregnant. Between smokers and non-smokers is between negative 0.17 and negative 0.03. And you can switch those to like negative 17% and negative 3%. Again, I'm flexible with which way you decide to do that. And this one's done. The only other thing now is they're saying, is no difference plausible? Like, is it plausible that if you compare the two groups, like there's zero difference? Like, the same amount are going to get pregnant regardless of whether you smoke or you not smoke? And that would be no. And again, what I want you to put on your homework, quiz, test is specifically to refer to the number zero, because it's a really big deal as we're doing standardizing, as we're doing, um, rejections based off of like intervals whenever there's two groups. So zero is no joke. We want to keep our eye on zero and use it primarily as our explanation whenever the time calls. But yeah, it's we're not now. They're not going to say that there's that smoking causes you the proportion to drop, but there seems to be an association that if you do smoke, you're going to be a lower part of the lower proportion that get pregnant. Since this is only an observational study, which I don't see how they could do an experiment. That doesn't seem very ethical. But all right, let's try the last one here. Um, Again, I want you to read this prompt for yourself. There's the table, and I want you to pause the video, right? And while the video's paused, write your HO, write your HA, what's being tested, less than, greater than, differs, mu's, p's, all that good stuff. And then right here, I want you to do like, what are the two main groups that are being subtracted? I want you to put fraction here minus fraction here. I want you to use just maybe a couple decimals here and then get your official, like what was the difference between the groups. But as you're looking at this here, I want you to see what two main groups are they focusing on, this group versus this group, and then what response are they focusing on the most so that you can scratch out whatever column or whatever row you like. I'm not even going to need that. So I'm just going to scratch it out because it's a distraction. That'll also help you make sure you get your correct fractions. Okay, so hopefully you've had an opportunity to try that. On this one, they are comparing the proportion of penguins that have a metal tag to those that have an electronic. And more specifically, they're trying to see whether those with a metal tag are going to survive less than those with an electronic tag. So for that reason, we can go and scratch out anything focusing on those that died, because the main thing is from metal versus electronic, who survived. And you can see our fractions right there for metal, 10 out of 50, and then 18 out of 50 survived for the electronic. So what we'll do is we'll come here. If we're doing metal minus electronic proportion wise, we've got 10 out of 50 minus 18 out of 50. And the reason why I was suggesting doing the decimals is because I think that gives us a real quick like snapshot. They had like 20% survived with the metal tag, but a higher 36% survived if they had an electronic, which would be a difference of negative 0.16. And I purposely wanted you to do metal minus survive so that we would get a negative statistic, which also corresponds to doing a left tail test. Now, the comment I want to make before we do part C is, first of all, just ask yourself a couple of questions. Like, was there a difference between the two groups and who survived? And yes, right, there was a 16% difference. However, when we get to doing this part, which is the standard error, what it's going to have us do is still at this moment suppose that this is true, that the two groups are the same, right? That there's no difference. Now, we just saw that there is a difference. 20% is not the same thing as 16%. But as I have it circled there, the null hypothesis is something we have to assume for a part of this hypothesis test, specific at the start of it, and then a little bit ways down, assume that it's true, that the proportions should be the same. But the issue is right now that they're not the same. They're two different proportions. So what we're going to do to create a proportion that would be the same, like the one and only proportion for both groups, is known as a pooled proportion. And that's what C starts to introduce. It says the overall pooled proportion of all penguins, and again, how many total penguins were there? There was 100. And of those 100, how many survived? 28. So this would be 0.28, which is the pooled proportion. Now, what that is the idea that suppose whether you wear a metal tag or whether a penguin wears an electronic tag, that it's not gonna matter. The same proportion is are gonna survive regardless, which would be 28%. That if you have metal tag, you're gonna survive 28%. If you're electronic tagged, you're gonna survive 28%. That's the polar proportion. And notice that it also splits the difference. Like it's in between 20 and 36%, like the two different proportions that happen for the two different groups. Now, what do we do with this? We're going to use it up here. but for both groups. Like the 28% is going to go for group one, and it's also going to go for group two, as if though it's the same. It's supposed to be the same result for both. 28% will survive for both groups. Again, that's just an assumption that what may be true is that the proportion that survive is 28% for group one and also for group two. Now, both of the groups had the same sample size, 50-50. So we're going to use that 50-50. Then the only thing we're missing now is the complement. And I'm just going to sneak that in like right here, just so somewhere that hopefully doesn't take up too much space. Complement would be 0.72. Now, you don't have to worry about, oh my goodness, I'm going to have to remember this. It will guide you on the homework to say, use the pooled proportion or find the pooled proportion. And the reason for having that is that you can use it to get your standard error, which that little formula right there, calculator, should give you 0.090. Now, it wasn't given at the very top, but on the test, it will. That if you're doing your converting to a Z, it's your statistic minus null over SE. And we've got all of those. Our statistic, well, that's this. The negative 16 minus our null. Again, our null, well, remember, whenever we're saying that the two groups are the same or have no difference, that's a null value 0. Here, maybe I'll sneak it in right here just in case you want it for your notes. This is null value 0. And then our standard error is right there, 0.09. And you don't need that extra 0. Yeah, if there's ever an extra 0, you can drop it. And from here, you should get negative 1.78. Now we've been using the standard normal already for a couple lessons now. So I want you to go ahead and take the negative 1.78, click whatever tail that you need, left tail, two tail, right tail, put that negative 1.78 down at the bottom, get your p-value. Remember, the p-value is not going to be 0.025. That's just the default p-value. And you should get something that's okayish, like not like the most smallest p-value, but not large either. Again, I'm just stalling right here so that you can try it. And then once you do have that p-value, I want you to maybe get your previous like notes that you've been using and decide whether we have enough evidence to be able to reject the null hypothesis or not. And here we go. Let me go ahead and do the p-value. Again, I was just stalling there to give you a chance to do it. If you're still doing it, pause me because I'm about to do it. And you're going to be doing left tail. And then at the bottom left, you're going to click the, again, left tail because we're doing less than. You'll put your negative 1.78 and click OK. And there's your p-value, 0.038. Now, make sure that whenever you're doing any of your statistics, your stat key stuff, that for your homework, anytime you use stat key, that's going to trigger that you're going to need to turn something in to be able to not, you don't want to lose points for just forgetting to include your stat key with your work. But yeah, since we're using a 5%, that would give us the ability to be able to reject the null hypothesis. That result is significant, statistically significant, most likely was not a fluke. So there is enough evidence to suggest or to support that. And then again, you're just going to restate what that was all about. That a low proportion survive if they wear metal tags. All right, but that is the end of another lecture. And if questions come up, let me know. Okay, now this 6.3 that we're ending here is the ending of unit 3, which means we're heading into test 3. So just make sure you've got your reference sheet. Know that formulas are going to be provided, like these square root formulas. And what I want you to do is, as soon as you get the homeworks done, uh, do the quiz. And the quiz will show you, the quizzes have always been to give us a representation of like what to expect on the test. So again, on the test, there'll be some p-values that are require you to count the dots, either on the left tail, right tail, two tail, which would mean to double. And then there'll also be some p-values on the test that are just given. Now, usually during the homework, you would need to use StatKey to go get p-values for some of your problems. But for the test, you won't have to open up StatKey and do anything with it. You'll just use the p-values that are already given. Reject, don't reject. Okay, the p-value is small, you can reject. There is enough evidence, dot, 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 dot. And and I think that's all that I've got. So I will go ahead and end the recording. And again, reach out to me if stuff comes up.